It's going to go right here to the board, if you will. And this is kind of an interesting question here. Move that up a little bit so you can see it a little better. It says, I'm not really sure what you call this kind of shape, but I'm supposed to figure out its volume. And if you can kind of tell right here on our board, it looks like it's like a tent shape, like one of those A-frame tent shapes. And so it's like a triangular
something.
tube. Yeah, tube's not the correct term.
Did you say prism?
A prism.
I would say a prism.
Oh.
I'm actually, and I like that you pointed out, it's a tent shape. This is a very old style tent.
Yes, yeah.
Okay, well, actually, that is how I camp.
Yeah.
You would. I
Yeah,
love
why
it.
is this not surprising to me?
I just
is
throw
not
up a tent
surprising.
and sleep underneath it, and I do the A-frame all the time. Depends on the one.
It's like a World War II
A-frames
tent or
are so easy that it's
Yeah,
like
they
an easy
are.
one to throw up.
Yeah.
Very simple.
Kind of rugged. It's a lot of fun.
Yeah.
It's like the real camping.
A little bit more breezy than the
Yeah.
other way.
When you sleep with your feet outside, too.
Yeah.
All right, so I just drew this figure really quickly on my sheet, and I'm going to take some information there. But so this thingy is actually called a triangular prism. Now, we'll talk about how you're going to find the volume of this, but I like to give a very generic formula. But really quickly, what this means is a prism is kind of this shape that it's a three-dimensional solid, so it maintains the same shape all the way. So, you know, one that you're probably more very familiar with is something like this. This is also a prism. This would be considered, one thing to call this is a, sorry, this always takes a little longer than I expect. This is called a square prism, and you probably are used to referring to it as a cube. But what we're kind of thinking about when we have these prism shapes, and the way you know it's a prism, is that it maintains its shape all the way. So if you can kind of visualize, kind of wish I had one of my objects I have in my classroom here, but if you can kind of visualize what this shape is on down here, this is a square shape, assuming all these sides are of equal length. And one way to think about this is like a prism maintains the same shape of its base all the way through. So if you imagine I were to stack this square over and over and over again on itself, it would make this shape. That's going to be true of this shape as well. It's a prism shape, and the actual definition says that it has the same base on top and bottom. It's the exact same shape. So where you see I have a triangular shape on this base, I also have the exact same triangular shape on this base. So that's one of them, identical bases. The other rule for a prism is that its sides are flat. So an example of what would not be a prism would be something that you're probably familiar with seeing, like, let me clear this out. Something maybe like this shape. Right, something like this. So you might be used to seeing like a can, right? This is very similar in a lot of the properties to a prism, but this is a cylinder. And again, it has two identical sides, assuming that my drawing was better. Both the bases are the exact same shape. They're both circles, but the side is not flat. So when we talk about prisms, they take a lot of shapes. So the prism aspect of it is that it maintains the shape throughout, or that it has identical bases and flat sides. But you could draw also a trapezoidal prism, which would look something like, oh, that's really bad. Let me just sketch it. It's not going to look quite as good. This takes too long. But a trapezoidal prism would look something like this, where I have a trapezoid shape, and it's three-dimensional, and it would maintain that same shape throughout. So I like to, when I sketch these, I try to offset them a little bit. But again, this is a really bad drawing. Again, this is a three-dimensional shape where it's got a trapezoid on both sides, identical trapezoids, flat all the way, like on all the sides. So when I set up this equation, I always teach my students to think of volume of any of these prisms as this formula. This is a very basic formula that will work for everything. And I think about this in terms of like, this is the area of the base, And this is the height of, you could say the object, you could say the solid. We typically say object, but it's the height of the entire object. So actually, do you have those dimensions again really quick? That's something I forgot to write down. Do you have that, Jeff?
Oh, sorry.
The dimensions, sorry.
I
I
zoned.
should have written that down, actually.
Okay, let's see here. Let's go back to. Let's see.
So we had some dimensions here, and we
Yeah,
said
we did. So we got okay. We got 24 centimeters high,
24 centimeters high.
19 centimeters wide,
Okay,
and 47 centimeters long.
gotcha. Okay.
So
I'm going to talk about those dimensions. Like Jeff said, it looks like the dimensions are that it's 47 centimeters long. That's one perspective. When we do these, I want you to think about actually, let's take a second. Let's take a step back really quick. We want to find the area of the base. When we think about bases of a rectangular prism, if I were to look at this kind of tent shape, like Sam may be familiar, he sets up his tent like this, he would think of the base as this rectangular shape down here, right? And you would probably think that because it's on the ground, right? It's like the base of your tent.
Right.
When we talk about prisms, when we talk about the bases, we're really talking about those identifying shapes. Like in this case, there's that triangle that makes up both sides. I always think of those as my bases. And again, because those are the shapes that are maintained throughout the entire shape. So when we talk about the base, I'm going to think of this triangle right here as the base. And again, look, these three-dimensional objects, they have different orientations. So I could lay this calculator flat and think that this is my base. I could set it like this and think of this as my base, and so like this. So the orientation is not really that important, which is why you can imagine this triangular prism being set on the triangle. So I think of the kind of identifying shape as the base of this figure. So in this case, the base is a triangular shape, and sometimes it helps to draw it separately. We know that this triangle has a height of 24. So I'm going to say that this is 24 centimeters in here. And we know that it has a base of 19. That can be a little confusing because there are a lot of bases here. But we want to say the area of the base, I don't know where those words went. I'm going to come over here and say that in this case, my base is a triangle. So we need to think about what the area of a triangle is. The area of a triangle is half its base times height. Now the difference between the capital B and the lowercase b is the capital B represents the area of the base, whereas the lowercase b is specifically talking about that triangle. So we could rewrite this formula and say volume equals the area of the base, which is now this 1/2 base times height. And I could say 1/2 base times height times the height of the solid. And again, if you imagine this figure here being laid on its triangle, then the height is going to be that 47 centimeters. So from here, we just have to plug a bunch of information in. And we can say that the volume equals 1/2 the base of the triangle, which was 19, times the height of the triangle, which was 24, and then times the height of the entire solid or object. And then from here, you could use a calculator, or you could just go through this step by step. But all we're doing is simplifying. Volume equals, you could do half of 12, which is 12, and then 12 times 19. Let me just do this in a calculator so I don't make a mistake here. Is 228, which is all of this, and then times 47. And we're going to get a volume of 10,716 centimeters cubed. So again, the reason why I like to use this very generic formula that volume equals the area of the base times the height is if I had some weird shape like this trapezoidal prism, I can find the area of the trapezoid, which you'd need to know the formula for that, and then I can multiply that by the height of the prism. So that really works for everything. You just have to make adjustments inside of the formula.